up, Song Squads? Our next lesson, solving polynomial equations. So our other unit, we talked about polynomial equations. How do we solve this? So anytime, remember the key word, when we solve, we are finding x-intercepts. That's the key thing. We're setting y equals 0 to find our x-intercepts. So we have to use synthetic. Our goal is to get the remainder to be 0. If you don't remember how to do synthetic, please watch my other video on dividing polynomial functions. The last question that I gave you, the advanced level, kind of piggybacks to where we're going to go now. So our goal is to list possible zeros. So if I have some function like this, let's go minus 1. Let's go let's go minus here and then plus 1 here. It's quadratic, but I want to use synthetic. So there's a method called the rational zero theorem. It's possible zeros. So we talk about P over Q. What P represents, P is going to represent all my factors of my A value or my C value, which is your constant term, divided by Q, which is your factors of your leading coefficient, your LC. I'm going to say LC for leading coefficient. All right. So in this case, that's my C value. This is my leading coefficient. So my options are plus or minus 1 divided by factors of your leading coefficient, just plus or minus 1. Fairly simple. So when you divide these guys, your only option with possible zeros is plus or minus 1. So what do? We do synthetic division. So you do 1, negative 2, 1. We plug in, we test one of these guys. Let's just try like 1. So if I try 1, you multiply, you get negative 1, multiply, you get negative 1, so you get 0. So that is an option. So what does that mean? Is that because you get 0 as your remainder, that means this guy is your x-intercept. This guy is your y value of the x-intercept, which is 0. That means if x is 1, that means my factor has to be x minus 1. So x minus 1 is a factor because we got 1 comma 0. So you have to kind of think backwards. Normally when we factor the problem and then we set equal to 0 and then solve for my x-intercepts. This time I know my x-intercepts. I'm going to go backwards and write my factors. So this is my factor, this is what's left over. So then we get x minus 1 there. Why? Because this is what was left over when we divide. This is my fully factored form. If we're solving it, we set it equal to 0. We set each term equal to 0. You don't have to do this twice, but I just wanted to show it. So we have an x-intercept at 1. Right? Because x minus 1 times x minus 1 is a factor, x equals 1 is an x-intercept. So remember, it's your factors of your C value divided by your factors of your leading coefficient. Obviously, if this was a higher polynomial function, then this guy, if this was x cubed, then this would be x squared. Then we would have to test to see, can we go further after we take out a factor? It's going to be x squared, so we need to see, can we go further on that? If it was x to the 4th, and we did synthetic, we got 0, then we get x cubed. And then either you try grouping. If that doesn't work, then you're going to try synthetic again and see if you drop the x cubed to an x squared. So synthetic keeps dropping that highest exponent 1 every time. Our goal is to get to quadratic, so then we can just factor it with all our methods. Factor guess and check, x method, box method, quadratic formula, or even completing a square to find the other x-intercepts. Because you can have irrational values, you can have imaginary values as well. So that concludes our lesson with solving polynomial equations. Remember, our goal when we solve is to find x-intercepts. We use synthetic. We use P over Q to find our possible zeros, possible x-intercepts. Then we have to guess and check. Luckily, this one was just one option, but you're obviously going to have something that has more options. You test it with synthetic, and then when you get 0, that represents that this guy here is an x-intercept, which means x minus 1 is a factor. This is what's left over. We can't factor any further. Once we have everything in factored form, we set that equal to 0 and then we solve. So try to repeat the steps in your head over and over and over while you do these problems so you get faster at it. Alright, so we're going to do our 3 problems, our basic, our intermediate, and our advanced problem. Good job. Alright guys, ready? Let's try this. If I give you x to the 4th minus 8x squared plus 12, I want you to list all possible zeros. List all possible roots. Roots, remember that just means x-intercept. So I want you to do P over Q, find all of them, and then list them all out for now. Alright, try your best, 30 seconds to a minute, go. Alright, welcome back, let's try this. P over Q. What does Q represent? Good, your factors of your constant value, which is 12, so write them all out. Plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4, plus or minus 6, plus or minus 12. Those are all my factors for 12, and then here, factors of 1, which is plus or minus 1. So these are my possible zeros. If I divide each one by 1, doesn't matter, we just get the top guy here. Alright, so check your answers. Our next step eventually is going to test these guys. Find your other factors, put in factor form, and then find your x-intercepts. Alright, good job. Okay, let's take another one. So you have x to the 4th plus 4x squared minus 32 equals 0. I want you to find me my x-intercepts. I'm going to do this the whole way. Remember with synthetic, I'll just give you a hint, we have to put in zeros wherever we are missing a term. So we're missing it here, we're missing it there. It's going to help you with the synthetic. All right, try your best, 30 seconds to a minute, go. All right, let's test it. So P over Q, factors of 32, plus or minus 1, plus or minus 2. Does 3 go into it? No. 4, 4 goes into it. Does 5 go into it? No. 6 goes into it. So 8. What else? 16 goes into it, and then 32. And same thing here, plus or minus 1. So we do P over Q. We just test it now. I'm just going to pick, let's just try 2. I don't know if it's right. We're going to try it since it's one of our options. You have 1, 0, 4, 0, negative 32. We test it. Hopefully we get 0. Fingers crossed. Drop the 1, multiply, bring it down, multiply, bring it down, multiply, bring it down, multiply. We get 0. Perfect, which means what? 2 is an x-intercept, which means x minus 2 is a factor. This is what's left over. So you have that plus 2x squared plus 8x plus 16. All right. We can do this again. We can group it, or we can actually use synthetic. Let's group this guy. So you have these guys and those guys. Here, what can you take out? I can take out an x squared, so you have x plus 2. Here, what can I take out? An 8, so you get x plus 2. So because they're equal, we can actually use grouping. So you have x minus 2. X plus 2 is my GCF. X squared plus 8 is my factors. And there we go there. So this is my x-intercepts down here. So it's x minus 2, x plus 2, and then x squared plus 8. Those are all my these are all my factors. So x-intercepts, all we have to do is set it equal to 0. We're actually going to do that in our next one. All right, good job. All right, our advanced problem, let's try this. X to the 4th minus 4x squared plus 3. I want you to do all of it. I want you to find me my x-intercepts. So start with your P over Q's. About a minute for this, try your best, go. Okay, P over Q. So you have what? Factors of 3, which is plus or minus 1, plus or minus 3. Factors of your leading coefficient, which is 1. Not too many check, which is good. Let's test 1. Don't forget your zeros. So square 0, 3. We're going to test it. Drop the 1, multiply, add, multiply, add, multiply, add, multiply, add, you get 0 there, which is good, because that means what? 1 is an x-intercept, that means x minus 1 is a factor. This is what's left over, these are your coefficients. So it's cubed, squared, x, nothing there. You can do grouping here, same thing like the other problem. Let's group it like this. So you can take out an x squared, you have x plus 1. Take out a negative 3, you have x plus 1. Because these are the same, we can combine it now. So my GCF is x plus 1. What's left over if I cancel this? X squared minus 3. So right now we have x minus 1, x plus 1, x squared minus 3. I want you to find x-intercepts. Set that equal to 0, so you get 1. Set that equal to 0, you get negative 1. Set this equal to 0, I'll show that one. Move the 3 over. Square root it. But when you square root, how many answers do you get? Good. 2. So you have 1, negative 1, and plus or minus root 3 are my x-intercepts. So check your work. Make sure you did this correctly. We started with pure of q's. Don't forget your zeros. We're trying to figure out one that gives me a 0 remainder. That means this is my x-intercept. Factor it after. We can do synthetic if you want to do more here. And then we just solve set equal to 0 and find my x-intercepts. Lots to do, but keep practicing. That concludes our lesson with solving polynomial equations. Hopefully this video helped you. Please subscribe to my channel, turn on your notifications, and let's get ready for some math videos. Good job.